Okay, welcome to part 2 of solving simultaneous linear equations using the graphical method. As opposed to part 1 where our two equations were ready to rock, being in the form of that y equals mx plus c, we can see here with these ones that if we do have a quick look, that they don't really look how we need them to be. So I've just got on the right hand side there, is it in the form of y equals mx plus c for the first one? No, it's not, and that second one is definitely not also. Alright, so there is a little video, it'll pop up on the left there for a few seconds, just going back and looking at transposing some equations. So they are in the form of y equals mx plus c, so feel free to jump back and have a look at that one as well. But what we're going to do is just going to work through these two here so that we have them in the form of y equals mx plus c, so we can go and plot them on the graph here and find our solution. So looking at number 1, 2y take 4 equals 10x. First thing that we've got to make sure is we've got our y's on one side and our x's and our constants on the other side. Okay, so at the moment we've got some y's here, but we've got a constant over here. Okay, so if we're looking at narrowing down and figuring out what we want to move, first we want to make sure that we get rid of this part here. Okay, so opposite of taking 4 is adding 4, and we're going to do that to both sides. And we get to here. Next thing, we know that we want to get that y on its own, so completely isolated, which means that we now need to go and remove this 2. Okay, the 2 and the y multiplied together, so we're just going to divide both sides by 2, which will get rid of that. Each time we want to eliminate something from one side. 10x divided by 2 will leave us with 5x, and 4 divided by 2 will leave us with 2. Just keep in mind that this divided by 2 needs to be applied to everything on that right hand side. So now we've come to the point where we are at the point of y equals 5x plus 2. We can now go through and identify our gradient and our y-intercept, as they are the two things that we need to be able to go and plot a straight line on that graph there. Okay, so our gradient is here at 5, and our y-intercept is here at positive 2. Okay, quick look at the second one. Again, we know it's not in the format, and what we need to get rid of on the left hand side to isolate y is these couple of things here. Okay, so I'm going to go and start by adding 8x and subtracting 12 from both sides. So add 8x and subtract 12. I don't need to do that across two lines of working out. So we're now left with 4y equals 8x, take 12. And we're pretty close there after one line. Okay, so see if you can group some things together if the equation allows us. Now on that left-hand side, we've got our y there, but we've got that 4. So we really need to isolate that. So we're going to divide by 4 on both sides. That eliminates. We've got y is left with, and remember, the divide by 4 needs to be with the 8x and also that negative 12, and we get down to equation of y equals 2x take 3. Same again, let's go and identify our two critical pieces of information that we need to solve this graphically, being our gradient of 2 and our y-intercept of negative 3. So once we've gone and got those two bits of information, we can now go across here and start to plot on our graph. Equation 1 has a y-intercept of 2, so we'll go and make little mark here at our y-intercept. Always start with that. And our gradient of 5 means that for every 1 we go across, we go up 5. So across 1, up 1, 2, 3, 4, 5 to here. Okay. If you want to plot another point, you can do the opposite and go down 5 and across 1, and we get to here. Then you can go and plot your straight line there, which I'll let you guys do. Second equation, we'll do this one in purple. We've got our y-intercept of negative 3, which is just here, and we've got our gradient of 2, also positive, which means across 1, up 2, across 1, up 2, and you can keep doing that as far as you need. So then you can draw your two straight lines, find your solution, and then check by subbing into equation 1 and equation 2 and making sure that left hand side equals the right hand side.